Fixed point number. Up until now, we have studied the basic radix representations of binary, octal and hexadecimal numbers. All of the data that is processed on a computer is represented in binary numbers. However, there is a need to represent negative numbers and fractions as well as very large numbers. For this reason, the representation methods are formulated based on Raj data format so that it can be represented by using the limited number of bits. The position of the radix point is fixed beforehand, and the method of representing the number in binary is the fixed point representation. It has a default radix point to the right of the LSB. This is often used to represent integers. The fixed point number length is usually determined by the word length of the computer. There are word lengths of 16, 32 and 64 bits. Fixed point numbers can also represent negative numbers. A concept called a complement is widely used in order to represent a negative number within the limited bit length. One. Complement. A complement is the resulting number of the subtraction from a certain reference number. Reference number minus given number equals given number's complement. This reference number is determined based on the number of digits of a given number in the radix representation. For example, in the case of a 5-digit binary number, there are two kinds of numbers that can become the reference number. 11111, base 2 maximum number of the 5-digit binary number. 100000, base 2 maximum number of the 5-digit binary number plus 1. In the case of binary numbers, there are 1's complement and 2's complement. Let us actually find each complement. 1's complement. The number that results from subtracting a given number from the maximum number within the given digits is the 1's complement of the given number. For example, in the case of 5-digit, 10111, base 2. 11111, base 2 minus 10111, base 2 equals 01000, base 2. 1's complement. 2's complement. The number that results from subtracting a given number from the maximum number plus 1 within the given digits is 2's complement of the given number. For example, in the case of 5-digit, 10111, base 2. 100000, base 2 minus 10111, base 2 equals 01001, base 2. 2's complement. Actually, when getting the complements simply, we can use a key property of binary numbers. Two. Method of representing fixed point numbers. In presenting negative numbers in fixed point numbers, 2's complement is often used. The method that represents a negative integer by using a 4-bit fixed point number is shown in the illustration. Take a look at the MSB, most significant bit. When the number is equal to or greater than 0, the MSB is 0. When it is negative, the MSB's 1. Since this law is applied, 1000 base 2 is not plus 8, but minus 8. The representation method of fixed point numbers is as follows. Example: 16-bit fixed point number. Range of fixed point numbers. Based on the representation method described before, when a 4-bit fixed point number is used, the numbers in the range from -8, base 10 to +7, base 10 can be represented. This range can be also represented as -2 to the power of 3, base 10, +2 to the power of 3 minus 1, base 10. The following indicates the possible range for each fixed point number length. As described before, in the case of simply representing the positive number including 0, the range that can be expressed is different. However, notice that the number of numeric values that can be represented is the same. In this way, in the case of a fixed point number of n-bit length, the number in the range from -2 to the power of n-1 to +2 to the power of n-1 minus 1 can be represented. If the result of the calculation of the fixed point number exceeds the range, it is called overflow. Advantages of representing negative numbers as complements. If the negative number is represented with the complement, subtraction can be performed by adding the complement. Example: since the calculation of 5 minus 3 can be regarded as +5 plus -3, addition is performed. By representing the negative number as a complement, an arithmetic circuit specialized for subtraction is not needed. Because of this, the circuit can be simplified.